Hello, I am Willem Mostert, and welcome to all of you who joined this webinar with Dr. Bredesen and Lance Kelly. Dr. Dale Bredesen is Chief Science Officer, and Mr. Lance Kelly is Chief Technical Officer of Apollo Health. Can I ask you to please mute your mic and switch off your video, as we have more than 400 participants registered, and as a result of this, it will be too complicated to have a question and answer session. We will, however, record this session and send you the link if you want to watch it again. You also can post your questions on my website, and it will be answered by an appropriate person. I will send out an email soon to explain the way forward. In addition, you will receive an email from Apollo Health that will contain instructions for signing up for the training at a special discount. And I want to thank Apollo Health for that. All right, let's get on with the show. When it comes to cognitive decline, the dominant current mindset is that there is no treatment to reverse it. My exposure, however, to the work of Dr. Bredesen convinced me that a solution to prevent and reverse cognitive decline is now available and being improved on a continuous basis. All we need to do now here in South Africa is to discard the current mindset and establish the capability to make the solution available to those at risk for cognitive decline. And we need your support in achieving this. I want to thank Dr. Bredesen and Lance for the help they give us. When I asked them for help, they did not hesitate to reach out. Before I introduce our presenters, I want to thank IIM, SASIM, Nutrition Network, and Biometrics for helping me to make this webinar possible. Dr. Bredesen will address us on the science of preventing and reversing cognitive decline, and Mr. Kelly, if there is time left, will present some aspects of the product through which the solution is executed. I want you to enjoy this with an open mind, please. I now hand over to Dr. Bredesen. Dr. Bredesen, thank you for what you're about to share with us and what you're about to do for our country. We really appreciate that.
Thanks very much, Willem. Great to be here. And Lance, I know you were going to say a few words before we get started.
Oh, thank you, Dale. I just wanted to tell everyone a little bit more about Dr. Bredesen's background. He graduated from Caltech and then earned his MD from Duke University Medical Center. He served as chief resident in neurology at UCSF and before joining Nobel laureate Stanley Prusner's laboratory as a National Institute of Health postdoctoral fellow. He has held faculty positions at UCSF, UCLA, and UCSD. And Dr. Bredesen directed the program on aging at the Burnham Institute before going to the Buck Institute in 1998 as its founding president and CEO. Dr. Bredesen currently serves as our Chief Science Officer for Apollo Health, the company he and I formed together. With that, it's my great privilege and pleasure to introduce you to Dr. Dale Bredesen, my friend and partner here at Apollo.
Thanks very much, Lance, and thanks, Willem. And it's great to visit your beautiful country virtually here. One of my, as I was telling Willem, one of my all-time favorite movies is The Endless Summer. It's got such beautiful shots of Durban and Cape Town and Cape St. Francis and all along the road there, just beautiful. So thanks very much. We have been interested for 30 years in what is the basic nature of the neurodegenerative process. My laboratory group and I published over 200 papers on what drives the neurodegenerative process. So I'll go through a few of slides here just to show you the background here, because if you understand the process, and it's quite different than we've been taught, then there's a tremendous amount we can actually do about it. This is as you know, this is a $1 trillion global problem that is unfortunately on the rise. It has many of the same comorbidities and risk factors that COVID-19 has. And so in fact, many people who are at risk for poor outcomes for COVID-19 are also at risk for Alzheimer's disease. And we're seeing this again and again and again. So let me bring up a couple of slides here to show you. We have created two approaches based on the research, one which is for reversal of cognitive decline that we dub RECODE, and the other one is PRECODE for prevention of cognitive decline. And I'll show you how these work here. So this was from when I was on a plane to London a couple of years ago, And you can see here, this is a guy who took his own life. This was a guy who was one of the very first pilots for the Concorde, who committed suicide. And why did he commit suicide? Because he had just killed his wife. And why did he kill his wife? Because she had Alzheimer's and he'd been told that there was nothing you can do about it. So this is the sort of thing, the horror stories that are going on all the time. We have 5.5 million people here in the US with Alzheimer's disease, but it's important to recognize, if you look at the entire population, about 15% of people, it is now the third leading cause of death in the United States, about 15% of people will die from Alzheimer's. So it's incredibly common. So of the currently living Americans, about 45 million of us will die of Alzheimer's disease. And we have, if you look at the most common genetic risk factor, ApoE4, there are about 75 million Americans and nearly 15 million South Africans who are ApoE4 positive and therefore at fairly high risk. If you have 0 copies of ApoE4, your lifetime chance for Alzheimer's about 9%. It's not 0, but it's not terribly high. If you have 1 copy of it, which most people don't know if they do or do not, but it's very important ultimately for everybody to know this and to get on appropriate prevention. 1 copy, your lifetime risk, about 30%. And if you have 2 copies, and that's about 7 million Americans, then you have a risk, a lifetime risk that is well over 50%. So it's more likely that you will develop Alzheimer's than you will avoid it during your lifetime. So this is critical for everybody to know. This is the sort of thing we want to change. But what I'll tell you today is really a story about much more than Alzheimer's. It's about how we practice medicine. It's about how we change the current standard of care. Here in the States, we've had over 400 clinical trials that have failed. This is a huge problem, and we continue to go failure after failure after failure because the root cause of the problem is not being addressed. And so that I'll show you how our research showed us over the years what you actually have to do to prevent and reverse cognitive decline. So this is really about changing medical thought and standard of care. I'm sure that many people heard about aducanumab, which was considered to be the most obvious candidate, the most likely to have a big impact. And so people were very excited about aducanumab over the years. It has failed now, and now the company Biogen has gone back to the FDA and asked for it to be reconsidered. When the FDA said, yes, we'll reconsider it, it looks good. It looks like we could approve it, even though the trials were failed. 1 dose in 1 trial seemed to have an impact, and it doesn't improve people. All it does is, at its best, slow the decline a little bit. And people were excited about that. The company's stock went up so that the company value increased by $20 billion in 1 day because the FDA sent out a note saying we will probably approve this. 2 days later, the expert panel of outside experts met and said, absolutely not. We recommend strongly against this. There's no evidence that this has an impact on Alzheimer's disease. Now, the FDA can still ignore that. They have until March, but this shows you how bad things really are. By the way, the stock then went back down the same $20 billion that it had gone up 2 days before when the expert panel recommended against it. So as everybody knows here who's seen patients with cognitive decline, the patients have been told, and we've all been told, there's nothing that can be done. So they often don't seek medical care until it's very late. They wait and wait and wait, which is just the opposite of what they need to be doing. We need to be getting people in for prevention or the earliest possible reversal. And in those people, virtually all of them do exceedingly well. But unfortunately, that's not what happens currently. People wait and wait and wait. They finally then go into a primary care provider. Primary care provider says, look, I don't need to refer you to an expert because I can write a prescription just as well as the expert can. They write a prescription typically for Aricept or Namenda. often without a firm diagnosis. And of course, that doesn't help people when they cold turkey it because there are often side effects. This actually makes them worse because this is an inhibitor of cholinesterase. Your body responds actually by making more cholinesterase. So if you now suddenly stop it, you're worse off than before you started it, unfortunately. And then, of course, finally, they continue to do worse and worse and worse. And they then send them to a specialist who says, I can't help you. I'm going to make sure that you can't drive. I will take away your driver's license. I will make sure that you can't get long-term care insurance. But would you mind coming back every 6 months for a lumbar puncture so that I can renew my grant? That's how bad things are, unfortunately, today. So we need to change that, of course. Here are just some of the many, many drugs that have failed in trials, and just a few of note here. Semagacestat, Lilly spent over $500 million developing and testing semagacestat. Not only does that not make Alzheimer's better, it actually made it worse. So it's worse than taking nothing. Dimebon here, as you can see, failed once. They couldn't believe it. They then did it again with Aricept, and it failed with Aricept as well. So this has been a real problem. There's something fundamentally wrong with the way we are thinking about and treating diseases like Alzheimer's when we are having 400 trials that are failing. Here I've mentioned 243 out of 244. That was 1 decade. There were 244 clinical trials. 243 failed outright. The one that succeeded, which was Namenda, has a minimal impact. And in fact, the people, the families couldn't tell who was on the drug and who was on the placebo. So that's how minimal the effect actually is. So we really need to begin to think about this disease quite differently. And the goal of our laboratory research over 30 years was to understand the fundamental nature, the molecular nature of the neurodegenerative process in enough detail that we could begin to fashion the first effective treatments. And actually, we were quite surprised to see what came out of the research, because it said that all the things that people were doing to develop drugs for this were really missing the most central point of what Alzheimer's is all about. So as an example, current standard of care, we say we don't know the cause of Alzheimer's, implying that there's one cause. We say this is one disease, it's Alzheimer's, and that we give one treatment, which is typically Aricept or Namenda, and it's ineffective. The research findings are quite different. What they suggest is there are many different contributors to this syndrome that we call Alzheimer's disease. And it's, again, a quite different process than we were led to believe. In fact, there are 6 different subtypes. There are people that have more of an inflammatory type of Alzheimer's, people that have more of an atrophic, people that have more of a glycotoxic or a toxic or vascular, etc. And therefore, there are many different personalized programs, and it's actually helpful to have a computer-based algorithm that looks at all the different contributors and that looks at, from those, what are the critical things to address. So the fundamental change here is that instead of predetermining a treatment, saying if you've got this, we're going to give you this drug, it's the opposite way around. You want to treat the cause, and the cause has many contributors. So you want to identify those for each person. You can determine why each person is suffering cognitive decline or risk for decline, and then target those things. And when you do that, you get unprecedented improvements. And we published the first improvements in this disease back in 2014, more in 2016, and then in 2018, we published 100 patients who had documented improvement in their cognition. So what this means is, because there are all these different contributors, if you wanted to develop a perfect Alzheimer's drug, and we spent years in the lab working on Alzheimer's drug and actually developed one that's called tropicitron that is that was in trials in Australia. Here's what the drug would have to do. So this is the problem. This is a tall order for a drug because there are all these different things that contribute. So this would be a little bit like saying, how can we improve the economy in a country after a recession? It's not just, you're not just going to change, one minister. You're going to have to look at what are all the things that are contributing to those problems and address those things. And no different with developing a perfect drug for Alzheimer's. You have to look at all the different contributors. So this is the very first person we treated back in 2012. So this is a person who came to see me in April of 2012. I hadn't seen patients in 20 years, but they had gotten wind of the research that we were doing. And so I met with this person. And by the way, she's now 76. She's doing very, very well. She's working without problems. She's now been on this for 8.5 years and doing extremely well. Interestingly, she went off the protocol 4 times. Each time she experienced some decline within 7 to 10 days, but she's now working, still doing very, very well. Here's another example. This is a guy I wrote about in the first book, and he's still doing very, very well. You can see here his quantitative neuropsych assessments, just dramatic improvements in his CVLT2. This is California Verbal Learning Test 2, Part B, total recognition of hits. His overall CVLT2 is auditory delayed memory, reverse digit span, just dramatic improvements. This was in 2 years. And typically it takes people 3 to 6 months to see improvement. This is, as you know, when you have a diagnosis of Alzheimer's disease, typically you've had the underlying pathophysiological changes ongoing for about 20 years. Okay, here's another person doing very, very well also. So this is someone who is on the East Coast, someone who is now 74, doing very, very well. Not only did she have improvements in her cognition, she had improvements in her hippocampal volume. She interestingly also had improvements in her PET scans. And we've shown in other people improvements also in their electrophysiology, in their P300B evoked responses, in their quantitative EEGs. So improvement in all fields, and including volumetrics, for example, as this person did. So just dramatic improvements. In fact, her PET scan went from compatible with Alzheimer's to not compatible with Alzheimer's. Here's another guy, 66-year-old guy with senior moments, very strong family history. Both parents had died with Alzheimer's. He had a single copy of ApoE4, already had a markedly positive amyloid PET, positive FDG PET, hippocampal volume reduced. Neuropsych testing shows that he's already into MCI very significantly. And as you can see, the things that are in his particular case that are driving this, he had an hsCRP of 9.9, should be less than 1. Homocysteine of 15.1, should be 7 or less. Vitamin D of 21. So this guy had multiple things. This guy is actually a brilliant physician who came to me at UCLA and asked me about if we ever had a drug that would make him better, would we let him know? And I said, actually, well, we haven't published the first paper yet, but we're working on something that is having good results. And he had many, many different contributors and actually has done quite well. He responded metabolically, cognitively, volumetrically. And in fact, here you can see his hippocampal volume went from 17th percentile here to 75th percentile. Actually, the neuroradiologist could not believe this at the time. And so we had to get the films. We sent them for another computer analysis so that they've had both NeuroQuant and NeuroReader, and they both showed the same thing, just dramatic improvements in hippocampal volume. You can see here his gray matter volume has also increased by 23%. So striking improvements for this particular guy. Here's a 62-year-old woman with dysnomia, executive dysfunction. And you can see here also single copy of ApoE4. You can see here she has some glycotoxicity, which is pre-diabetes, another common contributor, high fasting insulin. She also has a bit of inflammation with an hsCRP of 1.7. She actually has also low vitamin D. So again, multiple contributors to this problem. And she was negative for tick-borne and herpes family members. These pathogens, incredibly common. as contributors to cognitive decline. So she was put on the protocol we developed and actually did very, very well, improved her metabolic and cognitive status. Her MoCA score, Montreal Cognitive Assessment, went from 20 to 28. 28 is normal out of 30, 28, 29, and 30. She was able to run her business once again, and she's done very, very well. So to go into a little of how does the science actually work here, we've spent, as I said, many, many years, and at the center of all this is amyloid precursor protein. Now, people have tried just to impact that single molecule, but your brain is too smart for that. It simply goes around this. So you have no surprise, there are other pathways that lead to decline if you just impact this alone. So again, you have to get to the root cause contributors of the problem. But if you look at the biology of this, this tells us a lot about what Alzheimer's actually is. What is the origin of this disease? Why is it so incredibly common? Why has there been such failure in the treatment of this disease? So what you see is at the heart of this, so here we have, this is a type 1 transmembrane protein. The amino terminus is outside the cell, carboxy terminus inside the cell. Here's the cell membrane. This is a relatively common protein in neurons and especially at synapses. It's also present in other cells at lower concentrations. And most, as you can see, most of this is outside the cell. There's a tail here inside the cell. So this is a very interesting molecule that really serves as a gatekeeper, as a switch. When things are good, and it integrates over many different pathways, and in fact, it will sample. You can literally track the molecules by which this will sample the milieu of the cells. And when things are good, when you have enough trophic support, enough hormonal support, enough nutritional support, no different than what the president of the country would do when things are good, build and make connections, build infrastructure, et cetera. And that's the same thing that APP will do. When these are positive, it is cleaved at a single site here to produce two peptides, one outside the cell, it's a messenger, one inside the cell. And these are SAPP alpha and alpha CTF. These are essentially saying, yes, things are good. There's not a lot of inflammation. We're not being attacked by pathogens. We're not being attacked by toxins. We're going to be able to build and maintain synapses. On the other hand, when things are bad, when you have reduced support, reduced nutrient, reduced hormones, reduced trophic support, activation of NF-kappa B, inflammation, pathogens, toxins, poor vascular support, low oxygenation, sleep apnea, all these sorts of things, APP actually senses that, which is very interesting. So as a simple example, if you get exposed to herpes simplex, which has been repeatedly shown to be in the brains of many patients with Alzheimer's disease, this creates some inflammation, and your NF-kappa B enters the nucleus, affects hundreds of genes, and among those genes are the gene for the protein here, which cleaves, beta secretase, and the one that cleaves here, which is gamma secretase. And therefore, you push this in the direction of these guys. So again, you can literally trace the molecular pathways from these changes in your brain to whether your APP is going to support growth, synaptic formation. This is synaptoblastic activity versus synaptoclastic activity, pulling back. So very much like what you'd see with osteoporosis, where you have osteoblastic activity being exceeded by osteoclastic activity. In this case, it's a whole set of signals for synaptoblastic activity versus synaptoclastic activity. So in a mouse, we can fix that very easily because to do Alzheimer's, we just use a single gene. We can change that easily. In a human being, it's much tougher. We have to look at all the things that interact. And so here you can see APP. This is from work we published a few years ago that shows there are many, many parts of the APP interactome. So this does have to do with everything from how you're sleeping and your oxygenation and your vascularity and your B12 level and your homocysteine and your pathogens and your toxins, just on and on and on. So knowing these different different critical pieces, you can identify these and you can address the ones that are critical for each person. That's the goal. That is the future. That's 21st century medicine. So what we told people at the time is, it's a roof with 36 holes. You got to patch the different holes that are critical. For some people, there are going to be things related to inflammation. For others, it's going to be more about atrophic presentation. What we found more recently is, as people begin to improve, often we'll find a rate limiting step. So we call that ascending rate limiting step. So you have to identify what is the critical player here that's preventing these people. So for people will plateau, then you have to find out what is the critical player preventing them from getting still more improvement. The good news is, we see with prevention, we haven't had a single example yet of someone who's been on prevention actively doing the right things, but has then developed dementia. For people who have SCI, and you'll think about the four different periods, you have four different phases. There's a pre-symptomatic phase where you have the collection of amyloid, but you still don't have symptoms. Then SCI, subjective cognitive impairment, which lasts about 10 years on average. So you can see we have a tremendous window of opportunity. All of the people with SCI get better. That's relatively easy to do when you target the right things. Then if you don't do something about that, they go on to MCI, mild cognitive impairment, and about 5 to 10% of people with MCI convert to full Alzheimer's disease each year. So it typically lasts 2, 3, 4 years. And most of the people with MCI will get better. With Alzheimer's, some of the people will get better. We do have people even with MoCA scores of 0 who have improved, but that's not the, that is the exception rather than the rule. So we want to get in as early as we can, and nonetheless, we do want to get people started on this because that's what's required to get them better. So a number of years ago, we started a project. This has been ongoing now for over 10 years. And the question was, why does ApoE4 lead to Alzheimer's? Why is it the most common genetic risk factor? So I'll cut a 10-year story short into about 2 minutes here, just to show you, you can again trace the molecular pathways from ApoE4 to understand why these people are at increased risk for Alzheimer's disease. So it was clear from back from the early 1990s, the work of Alan Roses and Warren Strittmatter and others, that ApoE4 is the common critical risk factor for Alzheimer's disease, but it hadn't been clear why. The party line had been because you have less removal of amyloid from your brain. And yes, that is one of the impacts. You do have less removal of amyloid from your brain, but that's far from the whole story. And so what we found is that ApoE4 binds to a set of receptors, and that had been known before. But the surprise was that after it binds to the receptors, then what happens is it enters the nucleus, and that hadn't been realized before. Not all of it enters the nucleus, but a fraction of the ApoE4 enters the nucleus. It binds to REL-A, which is one of the parts of NF-kappa B. So it's an inflammatory related molecule. And it enters the nucleus and it interacts with 1,700 different gene promoters. So ApoE4 is not just carrying around the fat. It's not just your butcher who's carrying around the fat. It's also your senator who's making the laws of the land, because it's impacting 1,700 different genes. And if you group these genes and ask, what is it actually doing here? It has impacts. You couldn't tell a better story for Alzheimer's than what happens with ApoE4. So you can see here it impacts inflammatory pathways. What it does, it actually turns down things that turn down inflammation. So it gives you a more brisk inflammatory response. It affects microtubule disassembly. It affects glucose homeostasis, synaptic dysfunction, even aging and SIRT1. One of the promoters it binds to is the SIRT1 promoter. And if you look at the brains of patients with Alzheimer's, and we published this a number of years ago, you see a marked reduction, between 60 and 80% reduction in SIRT1 in the brains of patients who are ApoE4 positive who have Alzheimer's disease. And then it also impacts neurotrophin. So ApoE4 has multiple mechanisms by which it increases risk for Alzheimer's disease. And it does so in a way that is actually protective. So what we call Alzheimer's disease is really a protective response to these different insults. Very different than what we thought before. This is not something where the amyloid is being produced because it's bad for your brain, or it's not about misfolded proteins or prions or tau. These are all mediators of the problem. But the upstream causes are the ones that we want to identify and get at. And those are typically related to inflammation, various pathogens, various toxins, and then a reduction in the support for the brain. So at its most fundamental nature, Alzheimer's is a chronic insufficiency. It is a disease of insufficiency. No surprise, your brain shrinks. So it's an insufficiency in a global network that is a network of neuroplasticity, and that has dozens of contributors to it. So identifying those and addressing those is what works for these people, and the sooner the better, as I mentioned. So if you look at ApoE3 versus ApoE4, ApoE4 is a REL-A dominant protein. It is a pro-inflammatory protein. It's a protectant, whereas ApoE3 is SIRT1 dominant. These actually are cross-inhibitory. So these two pathways inhibit one another. So you either are dominant through the SIRT1 pathway or you're dominant through the more inflammatory pathway. And so you can see, again, this is why people develop Alzheimer's with increased risk. So the standard of care, as everyone's aware here, you wait for symptoms to appear and go to your doctor. 10 minutes, limited by the system. Often if you tell your doctor, well, what about this or what about that, or should you check this or that, that's seen as interference. They want to say, you're the patient, I'm the doctor, I'm going to tell you what to do, I'm going to give you a drug that doesn't help you. Sorry. As you know, when the doctors are evaluating people with cognitive decline, what do? We take a tiny data set, sodium, potassium, often TSH, often B12, not too much more. You don't have any computer-based algorithm that looks through all of these different things. You don't do a lot of genomics, those sorts of things. So these are the things that are actually driving the problem. Typically, we write a prescription. It doesn't have much effect. It's typically Aricept or Namenda, sometimes Exelon, but these don't have a lot. This, of course, causes people not to be able to get long-term care insurance. They lose their driver's license. They progress to a nursing home at high expense. They destroy the family's finances, and they die destitute. I mean, this is a horrible, horrible situation, unfortunately. So for 21st century, for the future, we want to have active prevention, reversal, and optimization, central coordination of evaluation and programs, social networking, and the wonderful website started by Julie G., who's ApoE4 for herself, as she pointed out, and did a tremendous job in writing much of the book that we just published together recently. The social networking has a critical impact to get the word out to many, many people. Please get on prevention or early reversal is huge. Using expert systems, which is why we're working with Lance in the group. He has a tremendous group from Silicon Valley. Lance worked at Apple for years, and they do a tremendous job with software. And so to be able to take a program and then continue to improve and improve and improve, we're able to look at more and more detail and get a better and better understanding, and then collecting the data ultimately so that AI will now tell us down the road, what are the most critical variables here? What's most important, what's least important? And then ultimately developing active insurance. In the US, there is no such thing as dementia insurance. But in fact, this is something that is needed and something that could now be produced because we can prevent people from getting this problem. And then continued optimization. The whole point here is to reduce the global burden of dementia, which is a huge issue. So we want to combine the current system, upgrade this, look at evolving programs to create a completely new system that will reduce the national and global burden of dementia. So how do we do this? First of all, we want to do for each person, determine what stage they are. And I should say, I'm going to summarize here what we've been doing now over the last 6 years. We actually applied for the first comprehensive trial back in 2011. So it's really 9 years since that. We were turned down because they said it has to be a single variable clinical trial. We're just finishing a clinical trial, and I'll show you a little bit a little bit of what we're doing with the clinical trial in just a moment here. But the point here is that we want to make it so that we develop programs that will prevent and reverse the problem. And you have to look at many different variables here. So first thing we want to do, we want to determine what stage. Are you pre-symptomatic, but you've already started the disease? You can look at that different ways. You can do that with spinal tap. You can do it with PET scan, but you needn't do either of those. If people, we recommend anyone 45 years of older or older, and certainly anyone who has any family history, please get checked. Anyone who's ApoE4 positive, please get on prevention. So we recommend that anyone 45 years of age or older get a cognoscopy, and you can do this direct to consumer. You can do this, get blood testing, and find out where you stand. And we'll talk in a minute about pre-code reports and recode reports. Then MCI, subjective changes plus abnormal cognitive testing. So by definition, you've converted to MCI when your cognitive testing is showing abnormalities. By definition, you've converted to Alzheimer's disease when your activities of daily living are affected. So then we want to determine what subtype. Type 1 is inflammatory, type 2 is atrophic, type 1.5 is glycotoxic. And the reason we call it type 1.5, it has features of both. So you get the inflammation from glycation of proteins, hundreds of proteins. Of course, we measure it as hemoglobin A1C, but there are hundreds of proteins that are glycated when you have high glucose chronically. And on the other hand, you also have insulin resistance. So you have some degree of an atrophic effect because you're not responding to insulin as you should. Type 3 is toxic, and these typically three groups of toxins. This is metallotoxins and other inorganics. And certainly here in California, where we've had such horrible fires and poor air quality, we are now at increased risk for cognitive decline because of the air pollution, which has thankfully been cleared out now. But that's going to give a bump. The people who were in the World Trade Center cloud, 12.8% of them had developed cognitive decline by 2015. So 14 years after the incident, a surprisingly high number of people had developed cognitive decline. And these were people, many in their 40s and 50s and early 60s. So this is a huge and important player here. So that's the first group of toxins. The second group of toxins, organic toxins, things like formaldehyde, benzene, toluene, all of these things increase risk for cognitive decline. And then the third group is biotoxins, very common. People who are exposed to things like trichothecenes from specific mold species. Trichothecenes typically are from Stachybotrys. So there are many mold species that are not a problem, but the big five that are a problem that we want to know about if these are in our homes. And again, people aren't bothering to check, but it's critical to know these: Stachybotrys, Penicillium, Aspergillus, Chaetomium, Wallemia. These are all critical, and they produce neurotoxins that are often associated with cognitive decline. And then type 4 is vascular, incredibly common. Many people do, because just as you'd have heart disease, with some cardiovascular disease, of course, you increase your risk for cognitive decline. It used to be said when I was training way back in the 80s that, oh, this is separate disease. This is a disease that is just vascular dementia versus just Alzheimer's. Well, it turns out that these are intimately interrelated, and most people with Alzheimer's disease have some degree of vascular insufficiency as one of the contributors to their Alzheimer's disease. So that's key to know. And then finally, traumatic. People who've had head trauma have an increased risk for cognitive decline associated with Alzheimer's. So the goals of treatment and prevention, and again, I'm going to go through these just as a summary. The training we've put together has the world-class experts. Dr. Neil Nathan, who's the world expert on biotoxins, has a whole section on biotoxins and what to do about them. Dr. Chris Shade, who's a real world expert on chemotoxins, has a whole and has developed all sorts of both analysis and treatment for chemotoxins, has a whole section in there. Dr. Anne Hathaway, who's a real expert in bioidentical hormone replacement. Dr. Cyrus Raji, who is an expert in neuroimaging and has published repeatedly neuroimaging in people with Alzheimer's and a functional approach to this. And then Julie G. Herself has got parts in this, who's really, I think, the leading, I would call the leading citizen scientist when it comes to helping many, many people. And she's the one who set up the very important website, apoe4.info. So check that out sometime. So I'll go through these as a thumbnail, but I encourage everyone, hear from the world's experts on these various things, and you can really do a tremendous job with your patients and a tremendous job for your community in reducing the burden of dementia. If you look at this biochemically and ask, what are the things driving the decline? Here's what they are. So energetics, and I've put these in roughly descending order of importance. Most people have problems with energetics. And we know this because, for example, if you look at FDG PET scans, for people who are ApoE4 positive, even late in their 20s and 30s, you can begin to see changes where they don't have the optimal utilization of glucose. And what the PET scans show, which is classic for Alzheimer's, is temporal and parietal, so it kind of looks like two L's, reduction in glucose utilization. And as Dr. Stephen Kinane has shown, you can bridge that energetic gap. So when someone sees us, even with early cognitive decline, even at that point, there is an energetic mismatch. This is an emergency. You've got to bridge that energetic gap. And you can do that with a combination. Number one, you want to get them into ketosis. And at the beginning, fine, do exogenous ketones, no problem, for a month or two. In the long run, you want to get them into endogenous ketosis. And we target between 1 and 4 millimolar beta hydroxybutyrate, or if you use the breathalyzer, and Biosense came out with a very nice, accurate breathalyzer recently, which looks at acetone, you want to get above 7 ACEs. You want to make sure they have appropriate cerebral blood flow. Many people don't. They're not exercising, they've got a sedentary lifestyle, they've got some degree of vascular disease, etc. And then oxygenation, surprisingly important. And there was a nice paper published a few years ago showing if you just look at the mean SpO2 nocturnally, it correlates beautifully with the volumetrics of specific nuclei within the brain, and this includes hippocampal region. So if you've got people dropping their oxygenation, and these are not just people who have sleep apnea, these can be many different people, and if they are dropping their oxygenation at night, this is associated with a decrease in cerebral volume. So getting these things together, and that includes supporting mitochondria, this combination will give you optimal energetics. And then insulin sensitivity. Professor Ed Getzel from UCSF did a beautiful study a few years ago looking at neural exosomes. So you can literally get an idea of what's going on inside the brain. These things there are about 1.2 billion of these things per cc of blood. So these tiny little cellular fragments that are floating around in your bloodstream, great way to look at what's actually going on because they come from different organs. And as he published, 100% of people with Alzheimer's disease in his study turned out to have insulin resistance. Whether they had it peripherally or not, they had it centrally. So this is a critical thing to address. And in fact, we can address it very successfully with appropriate diet, exercise, sleep, stress. So an appropriate strategy to address insulin sensitivity. And of course, there are all sorts of things in addition, things like berberine and things like, in some cases, metformin, things like N-acetylcysteine, all of these sorts of things that can be very helpful. And now with continuous glucose monitoring, you really can get an idea of where people are standing, what's actually impacting their glucose, what's actually causing spikes, and what's causing troughs. And again, troughs is a problem as well. People will go to sleep at night and drop their glucose into the 40s or 50s, not realize it. They may wake up in the middle of the night and not know why. And so this is, again, important. It's because they don't have enough fat. They don't have enough slowly metabolizable substrate. So you're now metabolizing glucose and simply dropping into a trough. Bad for your brain. And then trophic support. As I mentioned, growth factors, hormones, nutrients, we now have the ability to affect all of these things. And so, in fact, we've always been told that there is no arsenal, that there is, quote, nothing that will delay prevent or reverse cognitive decline. In fact, it's the opposite of that. The arsenal is huge. You have many things that you can do to impact cognitive decline. And among the trophic factors, of course, BDNF, which you can increase with things like exercise or whole coffee fruit extract, very important for Alzheimer's risk, and nerve growth factor, also quite important. You can increase that with things like ALCAR, acetyl-L-carnitine, also things like calcium erinaceus, which is lion's mane. All of these things can increase nerve growth factor. And then resolution of inflammation. As Professor Charles Sirhan from Harvard showed a number of years ago, it's not just about an anti-inflammatory, it's about resolving the ongoing inflammation. So he developed resolvins, and you can use these SPMs, as they're called, specialized pro-resolving mediators, to resolve ongoing inflammation. Then, of course, you can prevent future inflammation with things like omega-3s and curcumin and ginger and things like that. But the most important thing is determining what's actually causing the inflammation. People leave that part out, so they continue to have, whether it's a specific pathogen that they're missing, whether it's a specific toxin that they're missing, they'll have this inflammation, leaky gut that may not be healed, metabolic syndrome, poor diet, on and on and on. Identifying the source of the inflammation, critical. And then, as I said, treatment of the pathogens and optimization of microbiomes, not just the gut, but also the oral and sinus microbiomes. Detoxification. This is a whole field unto itself, which is why I'm so glad that we have Neil Nathan and Chris Shade, two real world experts in this area. And then interestingly, people have done best with some degree of stimulation, which has been from light or magnetic stimulation, brain training, another one. All of these things create stimulation that actually helps with this synaptoblastic activity. And then improving the adaptive system. It's really interesting. In COVID-19 and in Alzheimer's disease, we see the same thing. It's just that in COVID-19, it's been compressed to 2 weeks. In Alzheimer's, we're talking about 20 years. But what happens is there is a mismatch between the innate immune system, what's the inflammatory part. Of course, with COVID-19, people die from cytokine storm. You have this massive storm of cytokines, but their adaptive system is not keeping up with the virus and clearing the virus, so that you end up with this storm. With Alzheimer's, it's the same thing, but now it's a cytokine drizzle instead of a cytokine storm. The A beta that has been vilified for people with Alzheimer's is actually part of the innate immune system. So as long as you have ongoing innate immune system activation, which is what these people have over the years, because of these various insults, and your adaptive system is not responding and clearing, whether it's herpes, whether it's P. gingivalis, whether it's Borrelia, whether it's Babesia, on and on and on. If it's not clearing these and resetting the innate system, then you will have continued Alzheimer's development. Just the same, again, same problem you run into with COVID-19. So we want to improve the adaptive immune system and reduce the innate system appropriately. Now, once you've done all these things, it's great now to reduce the amyloid, but this idea that we're just going to reduce the amyloid, which is what aducanumab did, without doing anything else, it does not help. And that's been shown with solanezumab, gantenerumab, crenezumab, bapineuzumab. All of these things came to the same conclusion. Removing the amyloid without doing anything else does not help. And in fact, we've seen a number of people who clearly got worse, presumably because the amyloid is a protectant. It is an antimicrobial peptide. But removing it appropriately later on is a good idea. And then finally, regeneration. And there are various trophic factors. I mentioned the hormonal support earlier, and then synaptogenesis and stem cells. So these things can all be helpful. So that's a quick thumbnail of the things that need to be done to give you the optimal biochemistry for turning things around and making and keeping synapses instead of continuing to lose them over time. And again, we've got tremendous experts who go through all of these. So you need to have a way to follow these different things. And so the team at Apollo has created this wonderful mobile app. They have some real app experts there, like Scott Grant, so fantastic people who are doing this. So you can look to see various parameters, and also, of course, pull in the data. So what are the various ketone levels that have come through Biosense as an example? So this will really help over the years to improve this. So want to mention a little about the trial. Working with three absolutely fantastic physicians, Dr. Ann Hathaway, Dr. Kat Toops, and Dr. Deborah Gordon. This is just finishing. We've been at this for over a year now. It's going to be finished this month, and so we'll be publishing it early next year. Very enthusiastic. It's the first trial in history in which, instead of predetermining a treatment, we look at all the different variables that are driving the decline and then target those. So this is a small proof of concept trial with just 30 patients. This is supported by the Evanthea Foundation, and we work with the QuestGen CRO. It compares the RECODE protocol to historical outcomes. As you know, historically, everybody gets worse and dies. The people here have done exceedingly well, and so we identify the various contributors and target those. The ARC project is something where we're now looking at, can we now take this to other related diseases, small numbers of people. So just like the ARC was 2 by 2 by 2, Noah's Ark, this is looking at small numbers of people with macular degeneration, with ALS, with Lewy body disease. And I should say the approach we've taken to Alzheimer's has worked nicely for some people with Lewy body disease who typically have specific toxins. We're now looking at these other diseases, things like PSP, CBD, etc. And this has just started with macular degeneration with a clinic in Dallas. So troubleshooting for people who've been on for at least 6 months, what's going on, what's not working and what is working. And so how well documented, have the suboptimal lab values been optimized? And I should say at Apollo, we have a monthly town hall. So people send in questions. We go through all the different things so that we basically have a community that's created that makes it so that everyone has the best chance for success. Have you achieved mild ketosis? How advanced was the process on presentation? The most common problem we run into is lack of compliance. It is relatively complicated. It helps to have a health coach to do this. The second most common is type 3 Alzheimer's. That is the hardest one to improve. These are people who sometimes have severe toxicity. And then, of course, we always run into people who say, I'm traveling the world, but I really don't want to do this. I'll do a little piece, then I'll wait a few months, and then I'll do a little piece and give me a couple supplements. And they don't really want to do this. And no surprise, this is a problem. They can't be bothered to do this. You really have to live this for 6 months to see what's going on. To get best results. So do you need a consultant related to CIRS? This is chronic inflammatory response syndrome. These are the people who have the biotoxins. Do you have undiagnosed sleep apnea? Common problem. Have you had regular brain training, and are you getting better on your brain training? Are you just doing supplements only, which typically doesn't work? The key is there's a threshold, very much like what Dean Ornish found with cardiovascular disease. It's the same thing. You have this synaptoclastic to synaptoblastic mismatch. You have got to get past that threshold to get people better. If you have continued exposure to the very insults that are giving you the problem, it's much harder to make it better. No surprise. And then surprising to me as a scientist who spent so many years in the lab, I have been surprised at how important purpose, joy, meditation, yoga, interaction. I used to think this stuff was unimportant, but the data from many, many groups has shown that, in fact, this is something that's important for improvement of blood pressure, improvement of cortisol, improvement of cognition, and neuroplasticity, and heart disease, on and on, depression, all of these things. So this is actually quite important. So specific reasons for failure: if you don't identify the contributors, if you have reduced oxygen concentration at night, if you don't get people into ketosis, typically ketosis is quite important. Failure to improve vascular flow, if you've got an unidentified vascular component, failure to resolve the inflammation and remove the source, continued stress, continued exposure to biotoxins, failure to heal the innate immune system to adaptive immune system mismatch, failure to optimize the hormones, not using a health coach. Common. People often have doctor shopping. They do something for a month or two, they go to the next doctor. Oh, don't do that, do this. That's not the way to go. And then not continuing to optimize. This is not you give one prescription, send them home, and don't see them for 3 months. You continue to work with them to make them better, and that's what works. So here's an example, and I'm using Julie herself is an example, someone who has ApoE44, as I mentioned, did very, very well. It went from the 35th percentile to the 98th percentile, and she's actually written a beautiful story about her own journey, which is coming out in a book next year. She also had mast cell, as many people do, mast cell activation disorder, which persisted. So she, after doing very well, as she pointed out, she began to backslide a little bit. And so the question was, okay, what have we missed? She had had an earlier prosopagnosia, which is facial recognition issues. So I recommended to her, anyone who has a non-amnestic part of their presentation is a concern. It's a higher likelihood then that there's some degree of either pathogens or toxins. And so I recommended to her that she get SIRS labs, and she ultimately did that. And these were markedly abnormal, and found out, okay, here's something to address. And it turned out that she was discovered to have babesia, which has been treated, and she has done better with that. So again, these things don't happen for no reason. When people are backsliding, look for what's going on. We published, as I mentioned, a number of papers to show that we could improve people. And here, this one actually has 100 documented examples of improvement. Electrophysiological in some of them, MRIs with volumetric improvements. All of them had quantitative improvements in their cognition. And published a book back in 2017. And the second book here is the one I worked on with Julie and also my wife, who's an integrative physician, Dr. Aida Lasheen Bredesen. They did just a fabulous job. So grateful to them. So the bottom line here is we have a potential that we've never had before for evaluation, prevention, and effective treatment of cognitive decline. We really have the ability to make dementia a rare problem. We have to change the way we think about it. We have to get people in earlier. We have to get more with health coaches. We have to change the paradigm here, but we really have a tremendous opportunity here. And we will make this a previous scourge, just as at one point, there was a scourge of syphilis. At one point, there was a scourge of leprosy, as polio was a big one back in the 50s and early 60s. And these will change. So this is going to change. And it's just a question of how quickly we can do it. So this really should be a rare problem. This is a protective response to insults. We now understand that. There are subtypes. We now understand that. We now understand we can prevent and reverse the problem. It should be applicable to other neurodegenerative illnesses. Each of them has a mismatch. In some, the mismatch is about neuroplasticity. In some, the mismatch is about energetics. In some, it's about mitochondrial complex 1, as an example, in Parkinson's, on and on. But they all have mismatches that are specific for their neural subsystems. So we should be able to have a big impact on the global burden of dementia. And as I said, just as for leprosy and polio, these should become a former scourge. So I'm going to go ahead and show an example of a recode report and a precode report. So hopefully everyone can see this. So what we want to do then is to look at a large number of variables that are the critical ones that are actually driving the cognitive decline. And the way to do that is to test these different variables. And some of these are historical, some of these are chemical, some of these are biological, some of them are looking at cognitive assessments. All of these come into evaluation here. And one nice thing is that the patients often say, yeah, I really appreciate I've got something, just as many people may have used the Cambridge Heart reports. The same idea here. This is a nice report for people to be able to look at. It explains things to them. It explains what their risk factors are, or what the things that are driving their decline. They can share it with their spouses, et cetera. And it also is a good thing for the physicians to look at, okay, here are the things. And this is not meant in any way to replace. In fact, this is supposed to be your assistant. So this helps you, basically making it more efficient and easier for you to look at, okay, here are the drivers. Of course, for many people, there will be additional tests that you'll want to order. So this is kind of in the sweet spot of, you don't want to have so few that you don't want to know what's driving it, but you don't want to demand so many for everybody that it's ridiculously expensive. So this gives a look, and then you can go from there. Do you want to look more at toxins? You may want to do additional tests there. Do you want to look more at vascular status, et cetera here? But this gives you a very good look at what's driving the process, and therefore an initial protocol for what you can do, and get you also plugged into the whole community. So I'll just zip through this. This just shows the table of contents here. Here's just a welcome introduction here. And then it will tell you what your index is. Here's someone that's in the orange, so they've clearly got some problems, but we see people who way over in the red, and we see others who are doing very, very well. Then it will list in order of the most important contributors. So this particular person, ongoing systemic inflammation is the largest driver of the problem. And the second one here, vasculature. And of course, people who have ongoing systemic inflammation have increased risk for vascular disease. Then it gives you the key metabolic contributors. And then it goes through each one with you. So here's your results. Where did you stand? Why is this important? So that the patient can look at this and understand a little bit about what was my value and why is it that you think I have A, B, or C. Here's glycotoxicity. This person actually had a hemoglobin A1C of 5.2% and a good HOMA-IR, less than 1.3. That's good. Then trophic loss, where did they stand? Is this something that's likely to be a contributor for this person? In this particular case, there wasn't a lot. The homocysteine minimally elevated, but not terrible. Toxicity here, dementagens, et cetera. It goes through each of these and then gives the results for those. Vasculature, your results, et cetera. And then trauma, et cetera. So it goes through each of the things and what's likely to be most important. People want to know, where do I start? What should I do first? So then we have this next part, which is where do I start? Here are the critical pieces that are giving you problems. And then we go through the different things, stress, sleep, supplements, et cetera. What is critical? How do you do the detox? And then a suggested plan. And I should say again, as a scientist and as someone who went through medical school and was told that nutrition is not that important, and that you just take a pill and that's good enough. I have to say, I'm surprised at how critical it is. It's not a cure for Alzheimer's, but it is an important part of the overall plan. Getting into nutritional ketosis, we use a specific approach we call KetoFlex 12-3. It does the things that give you the best neurochemical outcome, and that includes appropriate plant-rich, appropriate fasting periods, appropriate high fiber diet, phytonutrients. These are all the things that are critical for best cognition. And then this is the brain food pyramid and just shows what are the critical things from bottom to top here, and it really does change the way we think about food pyramids. And then all sorts of pieces here. And I should say that in addition to this, there are guides that Julie has put together along with Aida in some cases. These are fantastic guides to help people to look at, how can I improve and continue to improve. So this goes through all the different pieces of suggested plan. And again, this is supposed to be supportive. This is supposed to be an assistant for you. For the future of medicine, computers are going to contribute tremendously, and not just for data analysis and not just for electronic health records, but for helping the physician to understand many, many different variables for complex chronic illnesses. So it goes through all these different pieces, the suggested plan, et cetera. And then here we'll get down to I want to go through some of the raw results here. And then here are pieces. We've put together something because many people said that's too many pills to take. Okay, we have a way now to take fewer. And we've worked with a group called Life Seasons, which again, we're agnostic, whatever works. Some people like to use other things, no problem. Some people like to use Life Seasons. But the bottom line is you simply want to do everything possible to change them from a synaptoclastic environment to a synaptoblastic environment. So let's come down here, and then here are different things they can read. More on the plan. This is just the summary of the plan here. And then you can look at, this is about the mobile app that people can use. Here we go. And then the overview of the subtypes here. And then the various raw results. So as a physician, I find it helpful to look through the raw results here and just to look at, okay, do I agree with what's driving the problem? Do I agree with the overall plan? What are the things that I want to add now, additional things that I may want to look into, order, deal with, talk to the patient about, etc. So here's someone who had an AQ21 score of 3, which is relatively low, who has a MoCA score of 27. This person has MCI. And then critical historical pieces, not only for cognitive decline, but for differentiating between frontotemporal dementia, Lewy body disease, PSP, Alzheimer's disease. And so then looking at these various pieces, how has this person had, anesthesia multiple times? Another common contributor. Here you can see this person had a single copy of ApoE4, AG ratio of 1.4, which we'd like to see it at 1.8 or above. HSCRP is high, it's 2.5. So this person clearly has systemic inflammation. We need to understand, you can get an oral DNA test to look at whether this is being driven by oral pathogens like P. gingivalis, T. denticola, F. nucleatum, P. intermedia, things like that. Or is this being driven by leaky gut? Is this being driven by metabolic syndrome, by other problems? Here you can see actually not so bad on the glucose numbers. So the hemoglobin A1C is good. The HOMA-IR is 1. That's where we'd like to see it. Homocysteine is a little bit up, but not terrible. Vitamin B12 is good. You can see here, many of these factors are not risk factors for this particular person. Then you can look at toxins, you can look at lipids, you can look at the cytoprotection. So albumin in this person is a little bit low as an example. So this is really a person who's driven largely, who's got early MCI, ApoE4 positive, therefore should have a little longer on the fasting. And again, all this is included in the guides. But reducing that is going to be critical to improve this patient. And then for anyone with inflammation, you want to look at what is causing it. Again, this person, is it a specific pathogen? Is it a leaky gut? What have you? So in the interest of time, I think I'll just mention that the pre-code reports, and here's an example here, they look a little different. There's a little less overall information because prevention is easier than reversal, no surprise, but it's the same idea here. So we can go through pre-code reports, but again, in the interest of time, I'm going to stop there and turn it back over to Lance and Willem, and we can go through anything else you'd like to. So Lance, Willem, thank you. I'm going to stop the sharing here, and thanks again for the introduction. I think that
thank you, Dr. Dale.
Yeah, and this is something where we really can, for the first time, have a major impact on the global burden of cognitive decline. And so I look forward to working with everybody, and I encourage people to learn from the various experts in each of these areas so that you can have the best impact on patients.
Thanks so much, Dale. I think now, I believe Professor Tim Noakes wanted to say a few words, so I'm going to promote him to a panelist.
Thanks, Lance, and thanks, Dale. That was just unbelievable. It was so exciting to hear it. I hope you can hear me.
We
can hear you loud and clear.
Thank you, Tim.
And now you can hear me. I can
now
see
we can
me.
see you. Good.
Oh, fantastic. So that was just superb, Dale. It's lovely to see someone who's just pushing the frontiers and who isn't scared to do that. And you've been doing it now for decades. And you're finally now getting the recognition you deserve with your publications and your books and the recognition from the profession for what you are doing. This is such important work. It's so groundbreaking that it's really, well, I'm just absolutely excited to be part of it. I must just say that I'm glad you enjoyed Endless Summer, because you won't believe it, but when it came out in 1965, I went to Cape St. Francis and Jeffreys Bay in July 65, and we surfed both of them. And we surfed both of them. There was no one else out. It was astonishing.
Oh my gosh, you are so lucky. Everybody wanted to do that. Now, they had written a follow-up saying people were finding that the surf was not as good as advertised. And what did you find? Did you have good surf at Cape St. Francis and Jeffreys Bay?
At Jeffreys Bay is perfect, and it's just a unique break,
wow,
which is so designed that it was designed for the surf to break there.
Wow.
Cape St. Francis, it literally worked for like those 4 days that they were there filming, and it didn't work again, because you'll remember in the story they said that it breaks like this 360 days a year, but it
Right,
doesn't.
No. Yeah.
What happened next was that they built on the dunes so that the sand didn't go out into the rocks. And so that destroyed the surf. Yeah.
Oh,
So
that's
it might break once in a millennium. It doesn't really work. But Jeffreys Bay works unbelievably in July every year. It's just fantastic.
wow.
So
Fantastic.
anyway, to get back to, thank you so much. We've got such a high regard for the work that you're doing.
Thanks.
And it's so special to speak to people who are not scared, to push the boundaries and who ask questions. And I think what the bit I liked was there are so many factors. There are so many causes that you have to look at to reverse this disease. And that is what medicine needs to hear. And it's just fabulous to hear you say it and say it so eloquently and with such good evidence. And we know that you're going to win this one, that you're going to reverse the disease. And as you said, it's going to be less common one day, like we got rid of syphilis and we got rid of other diseases. And type 2 diabetes eventually will go as well, because so much of what you're doing will reverse type 2 diabetes as well. So thank you. And thank you for involving us. It was such a great privilege to see you and to hear you and to read and to hear about all the fantastic work that you do, and just to compliment you and say you're an amazing person, you're doing an amazing job, and wishing you every success in the future.
Thanks. And if I could just say a word about that, because when I was a postdoctoral fellow in Stanley Prusner's lab before Stan won the Nobel Prize, Stan was working on what he called prions, of course. And
Yes.
when I first joined his lab, I went to a conference that he gave at UC San Francisco. And I was standing in the back of the room, and as people were leaving, they said, "This is ridiculous." We could hear them. They're talking, "This is ridiculous. We don't believe any of this. There's no evidence for it. He's crazy. He doesn't understand what a slow virus is," on and on and on. So, anytime you're doing something different, there's going to be pushback. And I recognize, you may have seen the article published in Lancet Neurology a couple of months ago saying that our trials, we haven't done enough, we haven't published enough, on and on and on. Of course, you have to start somewhere.
Exactly.
And what we're saying is the science of what actually drives the degenerative process leads directly to this sort of clinical model. And we're seeing person after person after person get better. Now, with each thing, as we publish the trial that's just finished, that'll be the next step. But the idea that the person who wrote the article saying, "Oh, we weren't doing the right things," has nothing to offer, and is saying, "Well, okay, you're saying what you're saying is anecdotal." Well, yeah, where do you start? Yeah. So, okay, it's going to take some time. I recognize we have a lot of naysayers, we have a lot of pushback, but I challenge anyone, please take a few patients, try this, and you'll see it for yourself. I've had a number of doctors write to me and say, "I didn't believe this until my patients started getting better. And now I can see it again and again and again." And yes, it's not easy. And Julie will tell you, because she's been doing this for years very successfully, it's not easy, but it's giving us the ability to do something that can really change this huge problem of dementia that we have globally. So thank you very much for your comments, and thank you for your open-mindedness. I appreciate it. We all need to work together to make it so that we can see fewer and fewer cases of end-stage dementia.
Absolutely. And I do hope we'll be able to work together in some way. That anything I can do to support you would be to my pleasure and privilege.
Thank you so much.
All right. Well, thank you so much, everyone, for participating. Thank you for Professor Noakes for joining us here at the end. Thank you, Dale, for that amazing presentation. And Willem and I will be in touch with the group about next steps. And we really look forward to bringing this solution to South Africa.
Thank you.
Thank you very much, Lance. And we look forward to that.
All right.
Again, thanks, everyone.
Thank you, everyone.
Bye-bye.
Good night.